within the periodic table, we said that there are three major types of elements. I'm just trying to give you a preamble. There are three major types of elements. These are metals, non-metals. We also have those that are in between, which are called metalloids. And you see, as you go further in discussing chemistry, you will find that there's a bit of a discussion which is done within these within these metalloids, where we talked about a zigzag line, if you remember. But it's less talked about, I must say. Of these three, the longest of them all that we are going to look at are non-metals. This is the longest that we could have. In Cambridge, they call it the chemistry of the environment. It's quite long. So I want us to first look at metals. We look at metals for now, which even when we open is a thing that we are going to ponder on within the first few days of our term. So I'm trying to prepare for your mind. I'm trying to prepare your mind so that even when we open, at least you should have ideas of what will be discussed. So under chemistry, I'm saying we are going to look at metals. Now, these metals here, have properties. These properties, some of them are physical properties, and other properties are chemical properties. Physical properties are the properties that we can tell by the means of sight, by the means of a feeling, by the means of a smell, any physical form that we can contact these substances with, and they help us to identify that these are indeed metals. There are also those properties that we can only get to ascertain after carrying out a chemical reaction. So for now, let's look at physical properties of metals. Physical properties of metals. Now, it's quite small. Physical properties of metals. There are some properties that are common for all metals. There are also other properties that are only for specific metals. So I'll give you all the properties, but I have to indicate whether these properties are common for all metals or these properties are specifically for certain metals. So the first one that we can have is that metals are good conductors, of both heat and electricity. However, I did not use the word all. In certain situations, if the particular property is common for them all, I will have to say all metals. But here I said metals, meaning it is not all. There are, of course, those that are not good conductors of electricity, especially when they are in solid form. Okay? And these elements, of course, that are not good conductors of electricity, you can easily find them on the periodic tables. Okay. You can find them on the periodic tables. However, you find that certain elements such as bismuth, their thermoconductivity, the way they conduct electricity, elements such as bismuth, the way they conduct electricity is poorly. Of course, we also have metals that conduct electricity in a faster way. We also have elements such as tungsten, which is a rare metal. It's a non-conductive when it comes to electricity at standard pressure. So that's why you find that I did not say all metals. I said metals. Or maybe I should have said some metals are good conductors of both heat and electricity. Elements such as lead, elements such as titanium, some of these are least conducting metals when it comes to these physical properties. The second one is that metals have a high boiling point as well as melting point. So we're saying metals have high melting and boiling points. I said metals. Why am I saying this? It is because when we were looking at group 2 as well as group 1, in particular group 1 elements, which are called alkali metals, these metals, one of the properties that we actually looked at is that these metals are very soft. They can easily be cut with a knife. Lithium, sodium, these group 1 elements, especially the ones that are a little bit up as you go up the periodic table of group 1, they are very soft. Meaning, if they are soft, we expect their boiling point and melting point to also be lower. And we also have metals such as iron, metals such as copper. These metals that have got high density and stuff like that, you'll find that they are the ones that have got high melting and boiling point. But if they say, give physical properties of a metal, if they have not specified, you can give even this because they have not specified which metal that is. Property number 3, we are saying that metals, now these metals, I will specify at the end of the day. They have variable valences. It's not all metals, only transition metals. Transition metals are the metals that have more than one valences, but there is an exception, except zinc. Zinc is the only transition metal that has a fixed valence, and the valence for zinc is actually 2. But most of these metals, they have more than one valence. More than one valence. That's why when you are writing these elements, you indicate their valences. I'm sure you have seen somewhere written as copper 2, iron 3, vanadium 4, and stuff like that. It is because these metals, they have more than one valences. So when you are talking about them, you have to specify what is the valence of that metal that you are talking about. Very soon we will go to transition metals and then you come to understand this. Number 4, these metals that have variable valences, and again, except zinc, they formed colored solutions. And in most cases, these are transition metals. They will tell you that the valence, the particular valence that an element has, will determine the color of the solution. That's the reason that's why when you get a metal, you leave it outside in the presence of water, it's going to rust. And the color for rust is reddish brown. That color that we see, the ion which is there, it's ion 3. That reddish brown color that we see is because of this valence 3. But if you use the same ion, but if the type of the ion that you have has a valence of 2, the color will not be reddish brown, the color will actually be green. Many can be talked about. Talk about copper. Copper, especially copper 2. Copper 2 actually it's blue because of this valence that it has. Yet when you talk about zinc, you talk about calcium, you talk about any other metals, they have they don't have a color. And actually, as you go deeper in your fields of endeavor, they will tell you where that color comes from. They will tell you that the only metals that will have a particular color are the ones whose electrons they have a particular arrangement. If you pick an element, they will tell you that the best electron configuration that we have is where we put electrons in the orbitals S, P, D, and F, where they will tell you that these orbitals, S orbital can pick 2, P orbital can pick 6, D orbital can pick 10, and then F orbital can pick 14. Thereafter, they will also guide you that those elements that have got electrons in the d orbital going all the way up to 40, up to 10 electrons, those elements whose d orbitals are full. And an example is zinc. That's why zinc does not have a color. Those elements whose d orbitals are fully occupied, they will say that they do not absorb light, and at the end of the day, there is no color which is reflected. That's a little bit of a detailed chemistry, but it is important that you understand it that way. That's why it's not all metals that form a colored solution. Most of these metals are transition metals, and the reason that's why they form particular colors, it is because they have particular valences. So the potassium permanganate that we use in the lab to demonstrate the diffusion, the movement of colors in a solution, it is because of a particular valence that it has. Yeah. So these are some of the physical properties that we can talk about. Among others, we can also say that the other one is that they metals are all, let me not use all, are solid at room temperature and pressure. But it's not always the case. Even here, there's an exception, except for mercury. Mercury is Hg. Mercury is the only matter, which is a liquid at room temperature and pressure. And if you remember when we were talking about thermometers, we said a liquid in thermometer, what is put inside is either an alcohol or it can be mercury. It is because this mercury is actually a liquid. That is why we put it in the thermometer. If this mercury was a solid, it was going to be very difficult in its solid state to be put inside of a thermometer. They're quite a lot. They are quite a lot. We also have these three rather, that I'm going to put up, and also the clean match to transition metals. We are saying that metals are malleable. The malleability and the ductility, metals are malleable, ductile, and sonorous. So these three hard to pronounce terms. Running out of time. How much have I used? These are hard to pronounce terms, such as malleability, they are malleable, ductility, they are ductile, as well as them being sonorous. Sonorous, it's everything to do with the producing of a sound. When you get a meter, one end firmly held, the other end you hit it with a fellow metal, you'll find that it will vibrate. As it vibrates, it produces a sound. So the ability of metals to produce sound when they are hit, that's what we're talking about as sonorous. Malleability, you'll find that when they mine copper, they mine in big pieces. But out of those big pieces, when they do the refinery, during the procession, you'll find that different shapes are driven from those big pieces. The property of metals that makes it possible to be done that way is because they are malleable. Ductility, same applies to copper. When you get copper, you export it. When they make copper wires are very thin wires. So the ability of metals to be drawn into thin wires is what we call ductile. So ductility is the ability of metals to be drawn into smaller and thin wires. Then we can also talk about chemical properties of metals. Unless there are questions from the physical properties of metals. Questions? Questions, guys?
What did you say sonorous means?
The ability of metals to produce sound when they are hit.
Okay.
Yeah. Though in some form, in some way, they talk about it in terms of, they talk about it as a physical property, but the ability of hammering them into thin wires, it's nothing to do with the chemical arrangement. That is a physical aspect. Okay, and the last 5, I don't know how the time has run out so fast. So the chemical properties of metals that we can talk about are the following. One, And mostly when we talk about chemical properties, we're talking about the reactions that they undergo. Because that is the property that you can tell from a chemical aspect. Chemical properties of metals. So one of the properties that we can talk about, one of the properties, is that this property is common, but not for all metals. And that's the reason as to why after this, we'll have to look at the reactivity series, the ability of these metals to react with different substances. First of all, we're saying that metals do react. Metals do react with cold water to form a metal hydroxide, and hydrogen gas. When you react a metal such as lithium with cold water, that metal will form its hydroxide. So if you use lithium, we are likely to form lithium hydroxide as well as water, as well as hydrogen. So if it's lithium, which when reacted with cold water, and the only difference between cold water and hot water is steam, and therefore the state symbol is gas. We are saying lithium hydroxide is produced. Alongside, we also have hydrogen gas, whose number of atoms can be taken care of by the means of balancing. So you put a 2 here, you put a 2 here, and definitely you put a 2 here. This is what we are saying. Secondly, we are saying that these metals, when they are allowed to react, now with hot water, we're saying that metals do react with steam to form a metal oxide as well as a hydrogen gas. That is a major difference between a reaction with cold water and a reaction with hot water. So now allow me to use a different metal. Let's say calcium metal, when reacted with now steam, whose state symbol is gas, what is formed is a metal oxide. So this calcium will have calcium oxide. Then we also produce hydrogen alongside. That is the second chemical reaction. The other one is that metals react. Some metals, of course, not all metals can react with cold water. Not all metals can react with steam. We'll come and look at which metals when we look at the reactivity series. Point number 3. We are saying that some metals can react with dilute acids. Metals do react with dilute acids to form a salt and hydrogen gas. So you see, here water is not forming alongside the salt. Reason being is that, I'll show you. Let's look at this metal, let's say magnesium. Magnesium, which is just Mg, there's no oxygen. It's reacting with the hydrochloric acid. You see, HCl. There's no oxygen. So the only thing that will happen here is a single displacement where hydrogen is gonna be replaced by magnesium, and then hydrogen will be formed alone. And when this happens, you will see that what is formed is only magnesium chloride, which is a salt, a binary salt for that matter, as well as hydrogen gas. So you see, here there is no oxygen to be combined with hydrogen so that water can be formed. Therefore, it's only gas that is formed. It is only a gas that is formed. But if this was a metal oxide, if this was a metal hydroxide, the presence of oxygen on this metal could have made it possible that water is formed alongside. Okay, so these are some of the chemical properties that we can find in metals. Among others, you will find them as we discuss further. Unfortunately, we are running out of time, and I don't know how this time around we are only given 30 minutes. That's why I think going forward, second term, third term there, I need to upgrade this Zoom to premium so that we can have unlimited time to discuss all we want. But for